Now I've got two lines over here, two parallel lines over here, and I'm going to find out their gradients. Okay, and then we will figure out something over here also. So I'm selecting 2 points over here. First of all, I'm selecting this one, that is 0, comma 5. And what else I can select over here? If I take it like this, attach it over here, and when I will take it over here, so this will be minus 2, comma 1. Okay. Now, after that, if I take it straight in this direction and drop it over here, so one coordinate I'm getting over here also, that is 1, 2, comma 1 over here. And what else I can have? For instance, if I draw a straight line in this direction and then dropping it, so this is coming 4, comma 5. So I have a gradient over here. I have to find a gradient over here, and I am going to find a gradient on this line. The lines are parallel to each other, as you can see over here. So first of all, for gradient of this line, so m equals to y2 minus y1 upon x2 minus x1. M equals to, what will be y2? 5 minus sign 1 upon x2. What will be your x2 over here? 0 minus sign minus 2. M equals to 5 minus 1 will be 4. 0 minus minus 2 will be 2. So gradient of this line is coming 2 over here. That's the gradient of this line. Okay, the gradient of this line is coming 2. Okay, now, okay, let's change this thing. I'm not taking this one. I'm not taking this one, right? I've erased this one. I'm not taking this one. Let's take this one. Okay, I'm keeping it over here. I'm not taking it, but I'm keeping it over here. So anyone want to check, that person can check. I'm taking this one, 3, comma 3. Let's take the gradient of this one. Again, m equals to y2 minus y1 upon x2 minus x1. Okay, m equals to y2 will be 5 minus 3 over 4 minus 3. Simplifying it, 5 minus 3 will be 2, 4 minus 3 will be 1. So the gradient of this line is also coming 2. Now, you can see both lines are parallel and the gradient are coming same. It means if two lines are parallel to each other, their gradient will be same. Okay, you can write it if you want to. If two lines are parallel, their gradient will always be equals to same. Or if two lines are having same gradient, then their those two lines are parallel to each other. Okay. Question number 2 of exercise 7.3. The question says that there are 3 points P, Q, and R. P, Q, R are the 3 points, and the coordinates are given 2, 3. Q coordinates are given 4, minus 1, and R coordinates are given 7, 6. These are the coordinates given to me, and after that they are saying M is the midpoint of PQ and N is the midpoint of PR. Okay. Now they are telling us that we have to find, in a part they are asking for coordinate of M and N. Okay, this I have to find in my A part over here. So how will I find it? First of all, for M is the midpoint of P and Q, and the formula for midpoint is which I have told you in previous classes, x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay. Right. So what we are going to do, first of all, this one, xm equals to x, m means x coordinate of midpoint, y coordinate of midpoint. Okay. So 2 plus 4 over 2, comma, ym equals to 3 plus minus 1 upon 2. Okay. 3 plus 1 minus 3 plus minus 1 upon 2. So the coordinate will be xm equals to 2 plus 4 will be 6, 6 divided by 2 will be 3, and coordinate for this one will be 3 plus minus 1 will be minus 3 minus 1 will be 2, 2 upon 2 will be 1. So the coordinate of m is coming 3 comma 1. Okay. Now for n coordinates. Okay, n is the midpoint of P and R. N is the midpoint of P and R. So again, x coordinate of midpoint will be x1 plus y1 upon, sorry, x1 plus x2 upon 2, and ym equals to y1 plus y2 upon 2. Okay, so while I'm going to plot my value over here, xm equals to x1 plus x2 means 2 plus 7 over 2, ym equals to y1 3 plus 6 over 2, xm equals to 9 over 2, ym equals to 9 over 2. Okay, this is my n coordinate over here. Now, after that, they are saying that we have to show that, next part is they are saying show that MN is parallel to, the line MN is parallel to QR. Okay, the line MN is parallel to QR. How will I find out if two lines are parallel or not? So always remember, in order to find that two lines are parallel or not, you have to find their gradient. And if the gradient of two lines are coming equal, it means those two lines are parallel to each other. Those two lines are parallel to each other. Always remember that thing, that if two lines are parallel, their gradient will be same, or if two lines are having same gradient, then the lines are parallel to each other. Okay. So finding out, first of all, the gradient of MN. The coordinate of n is coming 9 comma 2 over 9 over 2 comma 9 over 2. Okay, and the coordinate of m is coming 3 comma 1. So formula is y2 minus y1 over x2 minus x1. Okay, so y2 9 over 2 minus y1 1 over x2 9 over 2 minus x1 is 3. Okay. After that, taking LCM over here, LCM over here, LCM in numerator, LCM in denominator. So multiplying this by this over 2, multiplying this by this, 9 minus 3 over 2. Okay. 9 minus 2, the result will be 7 over 2 upon 9 minus 3, 6 over 2. 2 and 2 will be cancelled. So the gradient of Mn is coming 7 over, the gradient of Mn is coming 7 over 6. Okay. The gradient of Mn is coming 7 over 6. Now I'm going to find out the gradient of gradient of QR. The gradient of QR. Okay. So what is the QR coordinates? These are the QR coordinates. Formula y2 minus y1 upon x2 minus x1. QR, your choice. Which one you want to take as x1 y1, which one you want to take as x2 y2. It's totally your choice. I'm taking this one as y2, 6 minus this one I'm taking as y1 upon 7 minus 4, okay, upon 7 minus 4 over here. Okay, one correction I have to tell. This is LCM I have taken, so this is 6. When I have simplified it, this is coming 3, and this is also coming equals to 3. Okay, simplifying this. So 6 minus minus plus 1 over 7 minus 4 is 3. So result is coming 7 over 3. So as the gradient of Mn equals to gradient of QR, so Mn is parallel to QR in this part. Okay, Mn is parallel to QR in this part.